Part 7. What is dimension? Based on the inner world, beyond the prism of senses, by Mohammed Babai. As mentioned in previous sessions, the purpose of these classes is self-awareness, and we need to first examine our five senses because they are the only way we connect with the world around us. We also discussed that vision is one of these five channels and provides us with three major categories of information. 1. Colorfulness of objects. 2. Size and solidity of objects. 3. Spatial dimensions of objects. Earlier discussions covered the first two aspects, and today we intend to explore the third category of information that comes to us through vision, which is the spatial dimensions of objects. But what is dimension? Dimension can have different meanings depending on the context in which it is used, such as in mathematics or physics. In mathematics, dimension refers to the degree of freedom or the independent parameters that are required to describe the configuration or state of a system. In this definition, we are not limited to three dimensions and could even have a different definition from length, width, or height. In physics, dimensions refer to the directions in which a particle or object can expand or move. In the three-dimensional world we commonly experience, these dimensions are the familiar length, width, and height. While physics introduces time as a fourth dimension, it is essential to note that time is merely a description of the change in the position of a three-dimensional object over a period, and it is often treated separately from the three spatial dimensions in most everyday scenarios. In this context, when discussing dimensions in the general sense, we are referring to the familiar aspects of three-dimensional space that we perceive in terms of length, width, and height. In the formation of dimension in our mind, the two senses of touch and vision complement each other and create a three-dimensional world. Now, let's see what information touch and vision provide to create the dimension in our mind. We can divide this information into two categories. First, information from the changes in the curvature of the eye's lens and also the different images received from the left and right eye as they are apart. As we explained in the second part, the physiology of the eye, light passes through the lens of the eyes and is focused on the retina. In other words, when we have a clear image of an object, the light precisely focuses on the retina. The task of reflecting light onto the retina is performed by the eye's lens. The eye's lens acts like a convex lens, and by changing its curvature, it alters the location of light reflection. Essentially, the closer an object is to us, the more curved the eye's lens becomes, and the farther an object is, the thinner the lens becomes to ensure that the light coming from the object is precisely reflected onto the retina. This way, the perception of distance and proximity is formed. Second, information through memories, experiences, and definitions that gradually form in us over time from the relationship between the lines of the image and the object's locations with the help of the sense of touch. For example, this image may appear to be a mix of meaningless color patterns, but by crossing your eyes and aligning two black circles on top of each other, the image transforms into a clear and three-dimensional representation. In this case, the image itself does not change. Instead, crossing your eyes causes changes in the eye's lenses, and with the brain's interpretation of shadows and lines, the image suddenly takes on a meaningful three-dimensional aspect, allowing you to perceive distinct shapes within it. In fact, our brain, utilizing the definitions it has learned about lines, curves, changes in the eye's lenses, and the distribution of light and shadows, along with memories provided by touch about the volume, extension, and distance, constructs this virtual image in a three-dimensional coordinate system. It transforms what initially appears to be a two-dimensional and meaningless image into a meaningful three-dimensional space with recognizable shapes. In reality, what we perceive as dimension is the result of the collaboration between our vision and touch senses, and the absence of this collaboration leads to the disappearance of dimension in the world we perceive. Here, the absence of collaboration between vision and touch does not refer to becoming blind or paralyzed. Rather, it means the complete absence of one of these sensory channels. An individual who becomes blind or paralyzed can still recall memories associated with vision and touch, but the sensory channel of either vision or touch cannot function properly due to a condition. For instance, a person who is congenitally blind may have a mental representation of an empty and dark space, but due to a condition in the visual pathway, they cannot see the reflected light from objects. However, they still have an understanding of space. To completely remove the vision channel, we would need to remove the eyes, the optic nerves that transmit visual information to the brain, and the part of the brain responsible for processing vision. To better understand this, consider the following analogy. If we have a PDF file but do not have the software to read it, the file becomes a package of unreadable and meaningless information. Now, if we remove the vision channel, all the visual memories will also be erased, and the light that reaches us will be like that unreadable and meaningless information in the PDF file. Interestingly, if our vision or touch channels were suddenly removed, we wouldn't even notice their absence. Since all memories related to that sensory channel would also be erased, we wouldn't be able to compare the world we experience without that sensory channel to our previous world, because we wouldn't have any memories that could be recalled. Therefore, dimension is the result of the collaboration between our vision and touch channels, and if one of these channels is removed, we cannot predict what kind of world we will be facing. Now that we understand how dimensions are formed in our minds, let's explore the concept of imagining worlds with higher or lower dimensions, starting from our three-dimensional perspective. For instance, to create a two-dimensional world, we need to remove one dimension, meaning either length, width, or height. Let's assume you are observing a person standing in front of you, and we want to take a two-dimensional slice of this person by removing the height and see how this person appears in the two-dimensional world. You might say that we can take a very thin, horizontal slice of this person, and that would be a two-dimensional image of her. However, even in this thin slice, there is still some height. To create a more realistic two-dimensional slice, we would need to take a two-dimensional slice of the constituent particles of that person. The building blocks of this person are atoms, where electrons orbit around the nucleus. Let's simplify things by taking a two-dimensional slice of just one atom. In a two-dimensional slice of an atom, the spherical nucleus transforms into a circular shape in the center of the slice, assuming the slice precisely passes through the nucleus. The electrons in motion become smaller circles that are constantly appearing and disappearing from our two-dimensional plane because they are orbiting around the nucleus, and they are not always within our two-dimensional slice. Now, if we perform the same operation for a horizontal slice of the person facing us, the resulting image would be a series of points blinking on and off, bearing no resemblance to the person. If we place this image in front of another person and ask them to guess what it is, they would have no chance of guessing. Now let's consider taking a two-dimensional slice of our entire world. What we would end up with is a series of blinking points that bear no resemblance to the world we currently observe. This exercise illustrates the difficulty of perceiving a two-dimensional world when we are used to living in a three-dimensional world. It emphasizes the significance of having multiple dimensions in our perception and how removing one dimension drastically changes our understanding and interpretation of the world around us. So, understanding a world with higher or lower dimensions is impossible for us, and we don't know how objects and creatures that we see in our three-dimensional world would appear in a world with higher or lower dimensions. The questions arise here: how would beings from worlds with higher or lower dimensions manifest themselves in our three-dimensional world? Is it possible for a stone in my world to be a different creature in a four-dimensional world? For example, is it possible for beings to exist in a four-dimensional world that we have no signs of in our three-dimensional world? In that case, can we determine the existence or non-existence of beings based on seeing or not seeing, touching or not touching something?